Solar panels are becoming increasingly common in the UK, but their uptake needs to accelerate. Traditional silicon solar panels are efficient at converting sunlight to useful energy, but they can be quite expensive and impractical for some uses. This is where a newer form of solar panel may come in handy: perovskite solar cells. These solar cells are becoming as efficient as silicon, yet differ in that they are made by simple solution processing and have the potential to be mass-produced using a roll-to-roll manufacturing, similar to the way newspapers are printed. This will drive the cost down significantly, making it more commercially viable to replace fossil fuel energy creation with solar energy. What's more, the perovskite cells can be made light and colourful, meaning they can be used in non-traditional settings like windows and on contoured roofs, so that buildings could power themselves. A potential drawback with the most efficient perovskite materials is that they contain lead, which is a cumulative toxin. If the perovskite cells get damaged, lead ions may leak, potentially causing environmental issues if lead ions are entrained into watercourses.
New research at the University of Manchester has made a discovery, though, that can potentially eliminate the lead release from broken cells. The team have taken lessons from nature and developed a perovskite solar cell which contains a bio-inspired mineral called hydroxyapatite, which is a major constituent of human bone. If the cells are damaged, this bio-inspired material acts as a failsafe, capturing and containing the lead in an inorganic matrix so the toxins are not released in the environment and are stored as an inert mineral. Another advantageous result from the use of the hydroxyapatite scavenger is that it actually makes the perovskite solar cells relatively more efficient by around 18%. An increased efficiency in panels means more energy can be generated and at a lower cost. The research team hope that the cells will bring forward the large-scale application of perovskite solar cell technology.